Welcome all to today's Passive House Alberta Building Better in Alberta webinar series, sponsored by the Alberta Eco Trust. My name is Frank Crawford, and I am the Education Committee Lead for Passive House Alberta. Today, we'll hear from Joseph Durr, who is the Team Lead for the Sustainable Buildings, and David Rulff, who is the Energy Performance Technical Lead, both at WSP Consult, about the recently completed cost study for the town of Banff on how you could achieve the higher energy performance tiers of different residential building archetypes in the Bow Valley area of Alberta. First, I'd like to thank the Alberta Eco Trust for their ongoing support. It is very helpful in allowing Passive House Alberta to continue our work. And as always, place your questions in the chat box and I will ask them at the end, or you can unmute and ask them at the end. So with that, please take it away, Joseph and David.
Yeah, thanks, Frank. Hi, everyone. Thanks for taking the time to join us today. So super excited today to present on our project that we did with the town of Banff. So it was looking at sort of potential pathways to achieve higher performance buildings in mountain communities. This presentation is one that we had previously done at the Canmore Building for Sustainability Conference in late last year. And so super excited to kind of represent the work for you folks. So this was a project that was funded through NRCan's Code Acceleration Fund. So just acknowledging the support of the federal government. Part of the reason why the town of Banff applied for this funding was that they have a greenhouse gas community emission target. So their goal is to try to achieve a 30% reduction by 2050 compared to their 2016 emissions baseline. And new buildings in Banff will be around for decades to come. And part of the challenge that Banff is sort of wrestling with is that just based on the current sort of landscape with their authority, there's not really an ability for them to sort of require higher performance. And so they are just looking at different ways to sort of nudge the new construction industry to higher performance through sort of voluntary means. And so this was kind of the purpose of our study, was to kind of do some exploration around this topic for the town. Our project team was both WSP team members, so both myself and Dave, but also sort of a big bench of folks who supported, from sort of our mechanical and building sciences folks through to our energy modelers and other folks who have worked a lot in this space. And we also partnered with a cost consultant, so A.W. Hooker, who looked after the capital cost estimating for a portion of our work. And then for ourselves, WSP, we primarily looked after sort of the energy modeling analysis, archetype development, and sort of financial, sort of more like holistic analysis that we did as part of the project. So what specifically were we asked to look at? So as many of you are probably intimately familiar with, under the National Building Code, there are sort of these things called tiers, which basically set different levels of performance for buildings to be able to sort of strive for. In Alberta, our sort of minimum performance is kind of tier 1. That came into force in 2024. And within each of the different or with, for depending on what kind of building you're building, they may be subject to different requirements. So there are some that are subject to the National Building Code energy requirements, so NBC 2023. And then, if you're sort of a larger building, let's say, you would probably be subject to the energy requirements set out in NACB 2020. So for our study, our focus for the building subject to NBC would be tier 1, which is again the minimum, and then sort of like 2 improvement steps. So looking at tier 3 and tier 5 performance. And then for NECB, sort of an analogous look, sort of tier 1, tier 2, and tier 4. And then obviously you can see from this table, and again, as I'm sure many of you are aware, there are sort of different requirements as you kind of climb up that tier ladder, let's say. And so looking at different ways that buildings would kind of achieve those. Under the building code, there's different ways that folks can show compliance. And so our study really focused on sort of the performance path, which is really, how most folks would approach these requirements with the most flexibility. So, we understand that there are different, prescriptive and sort of the mix between that and performance. But for our study, we sort of solely focused on performance, which is also why it was basically, an energy modeling study. So in terms of how we approached our study, so there was kind of four key steps. So the first step was archetype definition. So we understood from the town that, a lot of their upcoming development will be residential in nature. So we worked both with the town to kind of come up with what those, sort of what we felt were common or typical characteristics of those four different building types that we thought would be sort of most common in upcoming development for the town. After that, we looked at different design strategies that could be employed for the region that would be cost effective to kind of improve performance in over a baseline design. And then we actually conducted sort of energy and costing analysis on those sort of design strategies for each of the different archetypes. I think I will just clarify, and it's something we talk about later in the presentation, but the mandate that we got from the town was to consider cost-effective strategies, and how they define cost-effective for us was lowest construction cost. There are other ways to interpret what is cost-effective for sort of investment in your building, and that's something we'll talk about later in this presentation. So being a little bit more specific in terms of the four kinds of buildings that we looked at for this study. So we really looked at two sort of smaller residential type buildings, so a fourplex and a garage suite, which are, becoming, or, fourplexes and garage suites, I guess, to some degree, a little bit more common in sort of the Bow Valley area. Those ones were sort of the smaller archetypes, so really subject to the Part 9 requirements. And then we looked at sort of two larger archetypes, so an apartment building, which is sort of like, in that a low-rise MURB, not some sort of super tall one, but sort of like what you would sort of see typically in Banff. They do have some, uh, uh, like you won't see a lot of really, really big MURBs, right? You'll see sort of like these sort of smaller-ish low-rise MURBs, but still big enough to be subject to Part 3. And then as well as sort of a mixed use, which is, very similar to the apartment, except that there will be some sort of like commercial community type spaces sort of on the ground level. In terms of the kinds of design strategies that our team explored for each of those different archetypes, there's sort of four different categories that we kind of explored. So the first category was occupant connected systems and equipment. So that's things like strategies for lighting systems and plug loads. We also looked at enclosure and efficient HVAC delivery, because we were looking as well as, because we were looking at sort of higher performance, and GHGs was one of the considerations. We also looked at fuel switching strategies, and then sort of the last strategy that we looked at, which we're kind of calling grid stewardship, but functionally that was looking at sort of photovoltaic, so rooftop solar. In terms of our analysis, so when you do these kinds of studies, there's lots of different metrics and stuff that you can generate that kind of help you interpret the analysis that you've done. And so there's sort of a few different groups of metrics that we have produced as part of the study. So there are some obvious ones related to energy, for example, so energy use intensity, TEDI, as well as peak demand. We also did look, like I said, at, greenhouse gas emissions were part of what we were looking at. So we looked at operational emissions. So we looked at GHGI. And then in terms of cost effectiveness, so like I said earlier, we did look at upfront construction cost as one of sort of the metrics or outputs of the study, but we also did look at sort of some of the other ways to interpret cost effectiveness in the context of building better, which for us was looking at life cycle cost analysis. So not just thinking about the upfront cost, but also thinking about the potential impact of both the upfront investment as well as energy cost changes, based on sort of if you are incorporating more, let's say, energy focused strategies, as well as abatement rate, which is basically a measure of, how much emissions did you sort of reduce compared to a baseline design, and how much did you have to spend to sort of achieve those reductions. And yeah, this is just a summary of key assumptions that we used in our analysis. So like I said, we did a life cycle cost analysis. So we didn't just look at upfront cost. We also thought about sort of the bigger picture. So we did a 40-year life cycle cost analysis, as well as we did do an analysis of the greenhouse gas emissions, both considering, especially for grid electricity, considering sort of like the current grid carbon intensity, as well as looking at some of the projections that are out there for how the grid intensity may change over time out to 2050. So with that, I will pass it over to Dave, who will spend some time walking through sort of the outputs of the energy and costing analysis.
Thanks, Joseph. So yeah, we're going to go over in broad strokes the overall outcomes of the analysis. So for the next slide, these are the archetype energy results for the Part 9 fourplex and garage suite and the Part 3 apartment and mixed use across the baseline, mid, and upper tiers. One important thing to note here is that for more of an apples-to-apples comparison, the fourplex and garage suite results here do show all end uses, which, you know, when we're talking about the metrics and the code comparison that's required, those wouldn't be directly included in that comparison and for establishing how they achieve or meet those metrics. But this does show a better picture of the relative performance among the archetypes and over the tiers of performance. Ultimately, and again, in broad strokes, there were some common themes or common things that were required to achieve the mid and upper tiers. Generally, incremental and fairly substantial improvements to the enclosure, which included exterior insulation did end up being required even for the mid tier, increasing with thermally broken clips and quite a decent amount of continuous insulation on the exterior for the upper tier. The windows and doors also increased significantly in performance requirements. There was also reductions assumed for an air tightness, so for infiltration, which is we have to be a little bit cautious about, and we'll talk a little bit more later, but those were required to get to the upper tiers. And from a mechanical perspective, most of the mid tiers did end up requiring or incorporating some amount of electrification through switches to cold climate air source heat pumps with backup heating by either natural gas or electricity. And except for the fourplex actually was able to achieve the mid tier without that switch. Ultimately, to achieve the highest tiers of performance across the archetypes, it did end up requiring a switch to the ground source heat pump systems, even for these smaller buildings. So all of that is included in our cost estimates, but is a pretty common theme for all of them. So then in the next slide, the corresponding emissions results, you can see then there is the significant drop associated with switching to those heat pumps. And this is even considering the Alberta's current greenhouse gas emissions intensity. As it begins to decarbonize, the higher tiered performance buildings would approach zero in operational emissions. It is also very important to note that embodied carbon is not part of the study, so that was not something we captured here. So this is primarily the operational emissions. I guess next slide. And so then how does that correspond to things that a lot of you are maybe familiar with or care about? That is, and the overall goal of the project to some extent was how expensive is this? How cost effective are these measures? So this graph shows the upfront capital costs associated with each of the tiers of performance. The overall gray bars are the overall total construction costs. The colored portions are the cost, the design strategy costs, so the costs associated with the elements corresponding to what was driving, what was changed between the building designs and what drove the performance improvements. So what was part of the packages of measures needed to achieve the higher tiers of performance. So this is all unitized by the overall floor area, and you can see that there is some trends that we'll explore a bit more later, but that the mid tiers showed kind of marginal incremental either increases or even in times decreases in overall total cost. And it was the highest tiers of performance, especially with that switch to the ground source heat pump and more invasive or larger interventions across all elements, including the enclosure, that drove the a more significant increase to achieve the highest tiers of performance. So on the next slide, so when we're talking about that doesn't show the whole picture, the life cycle cost results, again, on a per meter squared basis, somewhat mitigate that jump in upfront costs. And we will explore this more later, so you can see a little bit more about how this is broken out. The highest tiers of performance for the part 3, the larger archetypes, the apartment and mixed use, the life cycle cost does increase towards the highest tiers. That is less of a noticeable trend though for the smaller buildings, which is quite interesting. So over the life cycle of the building, that implies that there's a trade-off between the upfront capital costs and other like operating costs and that sort of thing that end up providing a net benefit for, or at least stay stable for the smaller buildings. So in the next slides, I think, so now we'll get into what did we learn? We'll maybe get into some of the insights and some of the nuances of the results. So in the next slide, first, kind of high level comparison. Important to note that this is definitely not an apples to apples comparison, but it is important to put in the, establish some frames of reference and some context. Ultimately, the incremental capital costs or construction costs for achieving the mid tiers of performance was found to be relatively negligible across the archetypes. That's not even shown in the graph. Roughly, approximately 1% higher across the archetypes. The achieving the highest tier, though, did require approximately 5 to 11% increases in total construction costs. A big part of that drive is seen in some of the key building systems like the mechanical systems, so larger increases there that drove that overall capital cost increase. This scale of incremental cost increase compared to the other studies is lower than what has previously been reported, but does align with what's kind of being seen in transformations of the markets. So it's gradually getting less expensive to achieve those higher tiers as more products and service contractor availability that can achieve it, kind of meet these sorts of targets and provide the equipment at reasonable prices. It's becoming more and more available and driving high costs down. So the next slide. So incremental costs definitely focus on the incremental costs that are required to achieve the higher tiers are definitely driven by enclosure and mechanical changes. And specifically, while enclosure represents a significant, if not majority, proportion of the overall capital costs, its role relative to HVAC, actually, as far as the incremental costs, it decreases. It's really the mechanical systems is what I'm saying is driving in our MET packages was the primary driver of the increase in capital costs. And that can largely be attributed to needing to install geo-exchange for the highest tiers. There were trade-offs, though, if you get into the details of the changes in the systems. There were some trade-offs that occurred, and it's just a net increase for the mechanical systems that was driving it. The larger buildings did include the addition of photovoltaics on the rooftop PV, which had some impact as well. But ultimately, yes, you can kind of see the major overall driver and how for the mixed use building, for example, the proportion of the total cost for mechanical actually becomes greater than the proportion associated with the enclosure. All right, next slide. Oh. So Joseph, if you wanted to, I guess, carry on with the...
Yeah, I think we had some discussion here where, and this is something we actually talked a lot about with the town when we were kind of like working on sort of the beginning of the project is, cost effective, defining cost effective as sort of upfront, like let's say the cheapest thing to do doesn't really tell the full story of like why you should invest in sort of more efficient systems. And so that was something we really wanted to explore with them as part of our study. And so sort of part one of that idea of like upfront capital costs aren't the full picture of when we're looking at sort of reaching these higher performance goals is that you kind of lose some of the implications of trying to build as cheap as possible. So one of the big findings that we had was that just because you achieve a higher tier, so let's say sort of those mid tiers to that lowest tier, doesn't mean that you've actually translated that into lower utility bills, even though you've had energy savings. And so that was something that was really interesting to kind of pull out, was that because there was that shift in that mid tier from sort of a gas system to, right, like an electric based heating system, that there are some utility bill implications, especially in Alberta for the larger buildings that would have sort of the demand ratchet implications. And so in some cases, as you can see here on this graph, especially for the apartment, like the increase in utility cost, which would eventually have to be, probably borne by the residents or those that are residing in the apartment, increases significantly, so by 25%. And it is really just taking that next step, right? And then both investing in more efficient electric-based heating system and a better enclosure that you actually start to see the energy savings. So that was a little bit, right, counterintuitive, that even though you're building to a higher level of performance, it doesn't mean that, there are maybe some potential adverse implications that you don't think about if you're just thinking about the first cost to get there. Because in the last slide, right, the slides that we've just shown, right, like we kind of estimated that there was kind of an equivalent cost between that first tier and that sort of mid tier for most of the archetypes. And that trend is true kind of both across sort of the Part 9 ones we looked at, for the garage suite at least, because that was the one that kind of needed that electrification shift to get to that mid-tier performance, as well as across the Part 3 archetypes. So, sort of a significant increase in annual utility costs. The second part around, part 2 of our story, let's say, is that, just thinking about the cheapest cost and how that impacts energy cost changes is sort of this natural, the natural thing that follows is like, well, what's the big picture, right? Like if we think about owning this property for, in our case, we looked at a 40-year life cycle cost, right? Like does it tell a different story? And the answer is it kind of does, right? So another way that you can look at cost effectiveness is life cycle costs. And just because you have a lower cost to build doesn't mean that your cost to operate and own and maintain is lower. And so that sort of follows with that trend that there are increased utility costs in sort of that middle tier. So you actually have a higher life cycle cost. And that some of the incremental cost at sort of the highest tier is actually repaid by energy savings, because you do sort of invest more, you do get some energy cost savings. There is a little bit of sort of capital recapture as part of that tier, but also not in its entirety, right? So your energy savings that you would see at the highest tiers from our study, right, didn't fully show that they repaid the initial investment that you have to make to kind of achieve those energy savings. Some other interesting things that came out was, especially for the garage suite, was that the life cycle cost at the end of 40 years, you can kind of see it here on that bottom graph on this right-hand side, like the bars are kind of flat. And so that's actually super interesting, because that means the life cycle cost at the end of 40 years is very similar. And that's saying, even though you had to invest more at the start because of some of the sort of energy savings benefits that you would see, by the end of 40 years, you're actually not that much worse off in terms of financials by sort of doing that deeper investment from the start. We also want to acknowledge that, there's some co-benefits that we haven't fully captured in our analysis that could close the gap. Some of those things are really hard to quantify at this stage. I do think, some of like NRCan and folks are looking at ways to kind of help people sort of capture that. And I think there's some EcoTrust folks here that are also looking at that, right? But there's some things that are, there's sort of like insurance savings, there's also this sort of notion that buildings built to higher performance are more valued in the market, right? And kind of have a higher market valuation, but those things are a little bit tricky, I would say, to properly value in life cycle cost analyses as it is now. So we just want to sort of acknowledge that there are other benefits to building to higher performance that we haven't necessarily captured in this analysis. And then one of the other things that we talked about was around looking at emissions. So again, we did look at this thing we're calling abatement rate, or greenhouse gas abatement rate, which is really just a measure of how much did I have to spend to reduce 1 ton of greenhouse gas emissions. So if we look at sort of the tier 1 performance and look at the greenhouse gas difference for those higher tier performance of how many emissions we reduced, how much did we have to spend, right, to be able to sort of reduce the emissions of this new build, which is a little bit of a mind exercise because, for existing building it's kind of clear, but for new builds, you're just sort of comparing it to sort of like a notional design. But how this metric is kind of interesting is it does give us a sense of like the cost to invest now to reduce emissions versus the cost to retrofit later. And so what came out of our study was that the abatement rate, or again, that cost to reduce 1 ton of emission in operational emissions for these different archetypes, is that the abatement rate is much higher or in sort of what is seen for retrofits to achieve a similar performance as you would just sort of investing from the start. And I think that's kind of like a lot of people just have that anecdotally or notionally would feel that that is true. And so we have actually sort of produced some numbers that you can kind of see here. If you look at these graphs, like the difference is about an order of magnitude, right? So you will have to spend an order of magnitude more to achieve the same performance if you are, just assuming that you're going to be able to retrofit it later to achieve similar performance. The other thing that I think we talked about and was that, Banff has some community goals. And so, if the Alberta grid continues to decarbonize as expected, and admittedly, we wrote and did this study under sort of older Environment and Climate Change Canada emission projections. I think they're a little bit different now, but sort of this shift towards electric-based heating, which was generally observed between all the higher performance tiers, right, will sort of is like in direct alignment with that sort of community goal. And yeah, like I said, the cost delta between sort of, what you have to do, what you should invest in now versus investing in later, a lot of those cost delta are related to sort of like things that are just easier to address at the new build stage. So thinking about servicing, sort of like related infrastructure for certain ductwork, load reductions, orientation, stuff like that. So yeah, and with that, I'll pass it back to Dave for some more insights.
Thanks. So as would probably be intuitively expected, the switch to heat pumps, air source heat pumps, cold climate air source heat pumps, or ultimately to geoexchange will significantly reduce the emissions intensity associated with operating these buildings. There is a considerable supplemental heating requirement for colder mountain communities and pretty much communities across Canada, which should still be expected, but ultimately does not, it still provides a significant overall savings from the baseline into the mid tiers. And of course, GeoExchange then offers greater advantage in those contexts because of its ability to seasonally smooth over those sorts of peaks and provide much more consistent performance throughout the year. So the emission savings for the upper tiers is quite substantial, but of course there are challenges for implementation, especially in smaller buildings. So on the next slide, kind of associated with this actually is an important thing to also talk about. Another thing that comes up a lot and which is actually related to requirements for Part 9 buildings, the peak peak demand for electricity is something that gets talked a lot about in this electrification conversation. And for the larger buildings and for all of the buildings that switched to air source heat pumps, so the fourplex did not for the mid tier, so that's why the peak didn't really grow. But for all of the other buildings, there was either a small but not negligible or a very large increase to the overall peak demand from the grid. And this is because it's a very cold climate, and with a switch to air source heat pumps that even the cold climate air source heat pumps, they will perform worse at lower temperatures and at the lowest temperatures, and there will be supplemental heating required. Ultimately, that drives significant increase to demand at the peaks. So this is one of those, again, one of those other parts of the story beyond capital cost and simply achieving the energy performance and even the emissions targets for the mid and high tiers. You can see that the GeoExchange system does not really have the same issue. It either decreases or stays relatively consistent with the baseline as far as its impact on the peak demand from the grid. So this is something that wouldn't be reflected in most of the other metrics we're talking about, but is another one of those important parts of the conversation in deciding whether that first step, that cost-effective first step to get to the mid-tier is worth it, and under what metrics is that true, and where will it potentially cause issues if there's a mass adoption of it. So in the next slide, here we'll get into some other, these are now kind of a grab bag of other insights, a little more, some more of the specifics, since currently I think the detailed report's not available. So some other kind of insights that came out of the work we did. One, of course, is simply that higher tiers will require new skills and continued transformation of the market. There's a challenge and an opportunity. We had a lot of conversations within the team, with the cost consultant, with our subject matter experts and our regional experts. There's a lot of change. There's like both volatility, but also significant differences between regions, and things are also adapting and evolving very quickly. And this is reflected in the costing. When we do these sorts of costing exercises on specific studies or projects, things can change quite a bit year to year, and of course region to region. So we did put a lot of effort into an emphasis on this is a study for the town of Banff, mountain communities and identifying specific opportunities with that the region offered was important, and the cost implications of trying to achieve things like geo exchange in this context was important to really dig into. As well, this is already mentioned, so I won't go over it, but the town of Banff. So essentially, these are the overarching umbrella for the study was that these higher tiers of performance will have to be voluntary. So that has implications for what the sorts of measures and strategies we were evaluating and how we were presenting them and packaging them together. The intent was to align with initially, especially in the baseline, typical design, and to identify low cost and accessible options. Of course, I mean, we're speaking to Passive House. There are a lot of high performance options that are available, pathways for that can help achieve these higher tiers that are alternative to what we have presented. And another actually really important thing that was a big part of our analysis and reporting to the town of Banff, but we've kind of downplayed, haven't really talked too much about, is that of course there are changes that are now have essentially come out, but while we were developing the study, there were draft versions of the new NECB coming out, and the implications for provinces like Alberta, who have tied to those national codes to some extent, anticipating what those changes to the code might mean for this sort of decision making, this sort of study, and the decision making moving forward for what is baseline code compliance and what would the higher tiers of performance look like. One thing that we did find, though, is that since the new code is moving partly or provides pathways that are emissions focused, it actually can become, you can say, easier, but following those pathways for trying to achieve the highest tiers of performance can actually be more efficient, cost effective, because they give greater credit than the current relative pathways for decarbonization type strategies. So like switching to heat pumps and that sort of thing. So that's something very important to talk about. And then the next slide. So specifically on heat pumps, so a few other kind of key insights. There is a growing demand for cooling systems, even in colder climates. So this was actually a conversation we had, and we went back and forth and about whether our archetypes should include cooling or not, right, in the baseline of moving forward. Ultimately, the decision was to include cooling because it is being seen more and more. That wouldn't necessarily be considered typical of the kind of existing building stock, but it is becoming, it's anticipated that it will become kind of dominant moving forward. So cooling systems were included, and that did compound the benefit of switching to heat pumps, because consolidating mechanical systems for heating and cooling into a single unit is beneficial. So that is an important context to keep in mind. The cold climate heat pumps that were looked at, various types and specific equipment, they can achieve the higher tiers of performance at that upfront capital cost, but the operational costs, so like the utility bills and the peak graded demand impacts, shouldn't be ignored. They're part of the conversation. Even with, and that's keep in mind as well that those mid tiers did have significant improvements to enclosure and other areas. So that's even accounting for that demand reduction. The geo exchange has that significant greater upfront cost, but is a force multiplier, especially in cold climates, but really anywhere for providing the energy emissions and operating cost reductions, as well as the peak demand improvements. So there's trade-offs. The upfront capital cost is the big part, the big elephant in the room for that one. But there are, as far as skills and the equipment, these sorts of projects are appearing, they are occurring both in Alberta and in other regions. So this is no longer something that's necessarily just in the realm of like pilot projects. This is something that is being seen more across the board. And electrification of domestic hot water, I haven't spoken much about that actually yet, but that ended up being an important part for these buildings moving forward. And in fact, what we found was for the smaller buildings, actually, it was the equipment that that you can actually find equipment that was equal or cheaper than the gas-fired equivalents now, which is interesting to note. So then the next slide, finally, ventilation. So one important thing generally, of course, for residential buildings is ventilation. Considering ventilation, heat recovery, that sort of thing. The real benefits are present for small buildings, but it's one of those nuances of a study like this that is centered around Alberta code or around code requirements. They're not credited. So while it may be, it is an important element of designing, improving energy performance of small buildings and reducing the heating demand. It didn't play a big role in our packages because it wasn't credited. The larger buildings do get credit, and we found that in the case of the largest buildings with shared spaces and different space types, the centralized ventilation delivery actually in the highest tier end up providing some significant benefit, allowing maximizing the upheat recovery. And regardless of the approach, though, whether it's distributed units in the suites or a centralized ventilation system, maximizing, really squeezing out as much heat recovery as possible was a big contributor. And finally, on enclosure, some specific little insights we found was the insulated concrete forms for the below grade walls on the smaller buildings ended up being actually cheaper than the more traditional alternatives in trying to achieve the higher tiers of performance, and primarily due to labor cost differences. So that was, interesting to me, maybe familiar to the audience. The local design guidelines played a role in the types of options we had to consider and how things like the enclosure detailing would be done and how insulation could be added to the different elements. So specifically, they generally require or promote cathedral style ceilings and pitched roofs, but primarily still vented attics. So there was a lot of blow-in insulation in those attics, achievable to achieve the high performance needed. And for the walls, we did require exterior continuous insulation, but we did not move to premium double stud configurations for cost reasons. But there was a lot of conversation about that with our subject matter experts and about what types of assemblies are commonly available and the cost implications. There's a lot of conversation around there. And finally, air tightness. This is always a interesting and big one to talk about. All of the packages to some extent required air tightness reduction assumptions. We try to be as conservative as possible, only basing it on past studies and that sort of thing. But ultimately, a comprehensive air tightness plan is necessary, and that would include through the entire process attention to design details, both in design and during construction, and for the larger buildings, unit compartmentalization and suite level testing. So a kind of a full life project timeline. You need to have it fully integrated along the entire timeline. So then that would be it. Next slide.
Cool. Yeah. And, just want to touch on a few limitations of our work and sort of some potential areas of future work. So, Dave said the word conservative, so both conservative for energy modeling, but also that also applies to how the cost, the upfront capital cost estimate approach was. So, these are sort of what we call Class C opinion of cost, which has a big, pretty, plus or minus range. In general, the costs are meant to be sort of median. That's kind of how the philosophy of a cost estimate works. So, all those costs presented have sort of a big sort of plus or minus 20% accuracy kind of associated with them. Another one of the limitations and something we just always wanted to acknowledge because, when you do energy modeling and you think about air tightness, addressing air tightness through energy modeling is relatively simple compared to sort of, actually going out and achieving that in reality. And so that is something we just want to kind of like throw out there as, that we did assume air tightness improves as you achieve the higher tiers, which is necessary, right? But there is sort of like a practicality implementation consideration that's part of that. The other, limitation, and I would be interested once we kind of get to the Q&A portion to hear folks' thoughts around the call, right? But when you do sort of archetypal studies, we're trying to hit what is the widest swath of potential, features. And we do sort of admit that there are probably edge case or sort of other, very specific technologies and techniques that, could be part of the discussion for sort of cost-effective high performance. But they are kind of challenging to address sort of within the budget and the mandate that we have to kind of go forth and look into sort of those things. Areas for future work that we have put out there would be operational greenhouse gas emissions are just part of the picture. There's sort of this increased focus on thinking about embodied carbon emissions, especially at the new construction stage. And then yeah, Dave just touched on some of the other parts that I think it was like the last 2 weeks of the year they finally released the code update, the 2025 versions. So again, right, like even though it was part of our work, we were, our primary focus was on sort of the current in-force codes, but we acknowledge that that will change with time. So just rounding into the final lap here. So just key takeaways. So there's sort of 5 as food for thoughts. So the first key takeaway is that those middle tier archetypes or mid-tier archetypes, as we've been calling them, suggest that there is a cost-effective path to meet the requirements. Cost-effective defined as basically being able to be built for an equivalent cost as sort of the code minimum, which is tier 1. But there may be some unintended operational and grid stewardship impacts with those. So namely, potentially higher annual utility costs as well as higher peak loads on the grid. The second key takeaway, thinking about the upper tier archetypes, suggests that we didn't find a silver bullet. There's still a cost premium for achieving those higher tiers, which we estimated from our study to be around 5 to 10%, but this is lower than we have seen estimated for other studies, which sort of aligns with what I think what Dave mentioned was kind of there is sort of a market trend towards right equivalent cost and parity, and there are some specific technologies, especially around sort of electrification, where we're starting to see a little bit more cost parity. I think the example we pointed out was sort of those electric hot water, domestic hot water tanks versus sort of conventional gas fire. Key takeaway number 3 is that investment at the new construction stage is a more cost-effective way to reduce greenhouse gas emissions than retrofitting in the future, an order of magnitude different, right? So if greenhouse gas emissions are the name of the game, then there really should be a serious consideration for sort of that early investment at this new build stage. Another key takeaway, number 4, was that, heating with air source heat pumps did reduce operational emissions, even with the need for sort of gas as supplemental heating. Dave talked about that slide that, even though we do need backup heating in Alberta and across Canada, there's still a greenhouse gas reduction case that can be made. But there are some trade-offs, as we talked about, with sort of peak demand. And then the last was that, geo-exchange comes at a cost premium, but there are some sort of broader life cycle cost benefits that, maybe aren't reflected in the initial upfront cost. But if you take a more holistic view, there are some benefits that come from that sort of higher initial capital investment over the life cycle of the building. And with that, I think we hit Frank's time limit for us almost on the nose. That was great. And I'll just close by saying thank you everyone for your time and attention. We would be excited if folks had more questions that we can talk about now, but also, Philip, who was our client from Town of Banff, who couldn't make it today, certainly told me to let everyone know that you can reach out to him directly if you have questions about the study, and you're also able to reach out to Dave and myself, so we have our emails there as you need.
Excellent. No, you guys were perfectly on time, and yeah, an excellent presentation. And yeah, it's great to see that kind of we've been seeing tier 2 be kind of cost neutral for a while. It's nice to see that tier 3 is becoming more cost neutral, and that yeah, down to 5 to 10% premiums for the 4 or 5 tiers. That's excellent. So I have a bunch more questions. If anyone else does, either put your hand up or type them in. But if not, I will do a bit of follow-ups. So we've seen in other studies that PV really helps on-site photovoltaic generation, really helps with greenhouse gas emissions over the time, over kind of the life of the building. How sunny is actually Banff? Didn't seem to make that much of a difference in Banff. Would it be more of a difference in like Calgary where it is sunnier? Or what's your kind of thought on the PV and the importance?
You can go ahead, Dave, if you want. I would say,
I mean, that
sorry,
is, we did definitely have analysis anticipating it. Oh, sorry. Sorry.
No, go ahead,
Justin, were
Dave.
you
I
gonna
think
jump
I
in?
have some delay in my audio, so go ahead.
Oh no, I was just saying that, yeah, we did do the analysis specific to the site context, actually, and trying to anticipate some, well, a lot of the challenge.
Oh, David, it sounds like you're losing your sound too. Is that just me, or is that some sound issues now from David?
Is pitched roofs even larger. So even our larger architects did provide additional off. Al, can you continue?
Yeah, we lost you there for a sec, David. You seem to
Testing.
be okay. Yeah, now we got you. You came back.
Okay, sorry about that. I'm not sure what happened.
Yeah, technology happened. It happens.
Yeah, at least we made it through the presentation. I was just saying that there were some challenges associated with the specific archetypes for this location, specifically the pitched roofs, right? Like the design of these buildings had multifaceted roof designs with always angled roofs. So there was constraints on the available space for PV, rooftop PV, that we had to work around and anticipate. However, so I don't know if we have the specific analysis to bring up, but they did contribute quite a bit, which is why they're included. We only included measures that had, in that balance of cost effectiveness and ability to contribute. PV definitely contributed significantly in a cost effective way. It was just also one of those things that as far as was included only in larger buildings, there's conversations around what would be expected for bit depending on the scale of the building, but it was quite cost effective. And would it be, so as far as the cloudiness and like the weather context, there were other actually implications, like the mountains are up, so there's shading, there's the how many days of solar, so all of that was accounted for, and they still did offer. I don't have the exact numbers to pull up though, but they were included because they were cost-effective measures to include for sure.
Okay. It's impressive, yeah, that even with all those kind of detrimental things that are occurring in Banff, that PV still makes sense. So it makes really good sense everywhere else, and it still makes sense in Banff. Good to hear.
Even in, yes, yeah.
Another question: did you model kind of the full effect or the effects of full electrification, where you don't have any of the associated natural gas infrastructure, either upfront and ongoing, or did you always assume that there was a gas meter on site?
All of the higher tiers actually were fully electrified. I'm
Okay.
pretty sure, almost positive. And some of the middle tiers even, there was a switch from the supplemental heating. So some of the supplemental heating for the cold climate air source heat pumps was natural gas, but I believe I can check the larger buildings, I think switched to electric baseboard heaters for supplemental, among also supplemental within the coils within the heat pump exterior unit as well. But so there was actually full electrification. The domestic hot water was electrified in the mid tier. Whether there would be utility connections for appliances actually, I don't know if it might be one of the questions that comes up, but it's again one of those areas where for the smaller buildings we weren't within the code constraints, we weren't allowed to take credit anyway, so they're kind of just kept the same. As you're given what to use and you keep it the same. In the larger buildings, there's a little bit more flexibility, a little bit, and it's up to the code, like who's reviewing the code submission to some extent. But we did not claim very little, if any, savings associated with plug loads and appliances. But that's another opportunity, an area to explore in reality for buildings that are trying to achieve the highest tiers of performance, for sure. And one of those areas is, well, we electrified the main heating systems and domestic hot water. There might be other gas appliances and that sort of thing that in these buildings that could be candidates for electrifying, and then you'd have a fully electrified building, and that has, there's some resiliency implications, but also that could be a cost benefit as well for the initial servicing.
Excellent, thank you. So you talked a little bit about cooling, and I'm agreeing with you that really, yes, cooling is unfortunately no longer a luxury with the current climate that we're living in and moving into. So was the inclusion of cooling included in the tier 1 or not? Which I guess would only, again, if it wasn't included and it should be needed, it would again reduce the premiums to the upper tiers.
So there's a lot of back and forth about this, for sure. It is included in the baseline. Cooling is included in the baseline to have that kind of consistent comparison across the tiers. So we did include like DX cooling in the larger buildings, split systems, I believe, for the smaller buildings. But it was included in all of the tiers so that we could have that consistent comparison. Part of the reason was we actually went down a path of comparing with and without cooling. We had like cases that were with and without baseline, all sorts of mixed bag that a lot of it I don't think made it into the final report. And part of the reason for the inclusion of the cooling is partly what they were seeing in their market, but also as you move towards those, improved ventilation and enclosure, the cooling demands were actually increasing. There's significant opportunities in colder climates for natural ventilation and using like more passive strategies that we did not explore. But what was important was that we were, as these essentially, if we didn't include the cooling systems, the way in which these buildings have to be modeled, you would have the spaces were getting very hot, and you're getting a lot of unmet cooling hours, and the options available to address that are limited within the constraints of the code compliance. So it also kind of implied that we needed to, you kind of need to address it in the higher tiers of performance as the cooling demands inside these spaces gets larger in some way. And in reality, I think we did talk about it. It was at least touched upon in the discussion sections, but especially in sorts of places, there's significant potential benefit of natural ventilation and that sort of thing to address a lot of that. But yeah, still.
Excellent. Maybe talk a little bit more about demand charges and kind of those fixed plug loads and some of their impacts on some of the results. And and again, maybe if there's opportunities to use the ground source heat pump, which might drop those peak loads, which might take you off the demand charges, how impactful could that be?
Yeah, so that's something that is really relevant for sort of the larger buildings where you would have sort of like a central house meter that is metered sort of at like the commercial rate tariff. That's when those sort of like demand charges kind of enter the conversation, especially in Alberta. So, one of the challenges with sort of taking electrification at just focusing solely on electrification, right, obviously, is that your sort of peak in the winter for heating significantly increases. And then the way that the building structure in Alberta works is that you're actually penalized that on that throughout the year because there's a demand ratchet. So there's sort of, in our electricity system, once you sort of hit a big peak, you kind of are paying for it for the rest of the year. So that's where a lot of the sort of increase in operational costs we're seeing, especially for sort of those or larger building types. And so sort of having the strategies focused on demand load reduction, either through the tier 5 buildings, really mitigated those such that, your demand charges that you're paying sort of at tier 1 versus the higher tiers were, pretty comparable, but is definitely something that sort of is part of the business case. And, we didn't explore this. And to be honest, I guess it's probably a little bit newer for Alberta, but like, there are other opportunities to kind of do that peak demand shifting or reduction, right? So battery storage, some sort of like thermal solution that we didn't look into, but that is something that could be part of the equation that, will be important if we continue to kind of look at this electrification avenue. Maybe especially important as we think about existing buildings as well. But yeah.
Excellent. Yeah, again, it's great to see that the kind of tier twos and threes are no cost premiums. And I guess to maybe your comment about the double studs is that we have found in certain configurations that yes, double studs can be a very cost effective and low carbon way to meet the higher performances. So yeah, it's you have a big range and there's always ways to tweak it, but I guess we need to be looking more at it. The savings are there, I guess.
Yeah, we had that one for sure. Was a debate that went back and forth, and there were different perspectives. Ultimately, I think we ended up aligning with the direction from the cost consultant side, but there's a lot of opportunities specific to that, the details of enclosure design. How do you get extremely good performance out of different assembly configurations?
Yeah, if we're down to kind of 5% premium or 5 to 10% premium, you can really focus that on the beginning and hopefully drive that down with some excellent consultants working with you and some excellent kind of goals from the beginning.
Yeah, for sure.
Yeah, so one question, I guess, does a full study include a list of measures for each building that you modeled?
Yeah. So maybe I'll just say more broadly, right? Like our report was, in a very, very long report with very many data points. And yes, in the full study, there is sort of a detailed archetype and sort of measures matrix that is associated with each of the different tiers. So yes, we just didn't show that here because it becomes a very, very small text for everyone to be able to see it. So.
All right, so it definitely seems like I need to have a conversation with Philip about getting that report out public sooner rather than later. So we are going to be recording this. It'll go up on the Passive House Alberta YouTube website, and if I do get the report, I will try to put it there, and I'm sure we'll distribute it through many other methods. So yeah, we're coming up on the hour, so thank you both very much for sharing this very insightful and I think timely and important study that Banff had you guys create.
Thank you.
Yeah, thanks for the invite.